Another one is the scenario we call mMTC. This kind of large-scale machine-type communication scenario. We know now that we live in a society where everything is interconnected. The shared bicycles in our lives, they can all be connected to the network, things like water meters and gas meters in our homes, etc. They can also be connected to the network, including the smart cities of our future, right? Our infrastructure, our cameras, our streetlights, surveillance probes, etc. All can be connected to the network. We can achieve a smarter city. Of course, the premise is that we need to have perception capability. The premise of having perception capability is our sensors need to be able to connect to the network. So this is also a very important application scenario for mMTC, of course, including our smart parking lots, right? This has actually been applied. This is in our Shanghai Disney. Shanghai Disney has already done a pilot of smart parking lots. Actually, of course, this future smart parking lot scenario will enter more and more cities. But actually, we see that through this interconnection of everything, it has greatly improved the convenience of our lives. Another one is our URLLC scenario. A typical application of this URLLC scenario we talk about is our vehicular network, because for vehicular networks or for autonomous driving, what it needs is very low latency, because only very low latency can relatively ensure safety. If our future autonomous driving becomes a reality, then our intersections may no longer be congested, because through autonomous driving and vehicular networks, our cars and people, cars and infrastructure can all be controlled and dispatched. So our intersections may no longer be congested. This is our future vision for vehicular networks. Of course, we can also implement some vehicle platooning functions. For example, a logistics company, it has a large amount of goods to transport. It has 10 cars. We can group them into a team. In this way, our control and safety of the entire vehicle transport will be more effective. Of course, maybe traffic lights will also disappear, right? These traffic lights only exist in our cloud system, but we know that autonomous driving, it's about our safety because it involves our life safety. So it has very high safety requirements, similarly reflected in our mobile network. The requirement for latency will be very high. Here we give an example. We compared 3G mobile network, 4G mobile network, and the upcoming 5G. The typical value of system latency in 3G is 100 milliseconds. Of course, it may be a little lower than 100 milliseconds. The typical value of system latency in 4G is 50 milliseconds. Of course, it could also be in the 30s or 40s milliseconds, but the order of magnitude is roughly around 50 milliseconds. But for 5G, we mentioned it needs to achieve a latency of 1 millisecond. Then let's compare based on the system latency of 3G, 4G and 5G. Let's take a look. The braking distance of a vehicle, we have 120 kilometers per hour vehicle in motion. If it detects an obstacle in front, from detecting the obstacle to triggering the stop, we detect the obstacle. The information of this obstacle needs to be transmitted to the cloud through the network controlled by the cloud. Then the cloud sends the corresponding control information down to the vehicle. Then the vehicle can implement braking, then in the 3G era. Because of such a system latency, from detecting the obstacle to braking, the vehicle has already traveled 3.3 meters. If based on the 50 millisecond latency of 4G, the vehicle has also moved forward a merge 6-7 meters. If it is based on the 1 millisecond latency of 5G, the distance the vehicle has moved forward is only 3.3 centimeters. So in this way, our safety will be higher. Actually, this reaction speed has already surpassed humans. It has already surpassed humans. So it guarantees the safety of autonomous driving. It is guaranteed. So we see that is for autonomous driving, it has a very clear requirement for mobile networks. That is lower latency. Of course, the 5G network, it will enter through vehicular networks. Into our 5G network will enter our autonomous driving through its low latency feature into our vehicular network. And then because it has low latency, it can make our autonomous driving decision time shorter. And through vehicular network technology, it can also greatly improve the reliability of our decisions. Because we will connect different vehicles in the future, even pedestrians, even traffic signals, all connected to a cloud. In this way, the cloud can collect more data cameras. Our onboard cameras, onboard radar data reported, data reported by our traffic signals, some sensors carried by our pedestrians, such as mobile phones or smartwatches. The data reported by it, we report all of them to the cloud through the vehicular network. The cloud makes unified judgments and processing, so its reliability will be higher. Of course, reliability is relative to what the traditional single vehicle autonomous driving technology, because we know that Tesla, before including the new generation Audi A8, they all have some autonomous driving functions. But its function is based on a single vehicle. The entire detection, processing and control are all done inside a car. But if you are at an intersection, you can only detect the information around you, but you can't detect the oncoming car from another direction. So there is a certain problem with its safety. But if we use this vehicular network technology, all vehicles in the future, including our infrastructure, including our pedestrians, all information will be gathered in the cloud. The cloud makes more accurate judgments based on more data. By the cloud, more accurate judgments. So its reliability will be higher. Of course, all of our information transmission and control command issuance are based on low latency. Okay, these are the 3 application scenarios of 5G we introduced. Then we have eMBB, mMTC and URLLC 614. We combine each scenario. We also look forward to valuable or some new businesses and applications that will come quickly. Our eMBB scenario VR, then the application of the Internet of Things in the mMTC scenario, including our URRC's vehicle networking application. Of course, for the URRC's vehicle networking application, it may not come so quickly because it is restricted by some legal regulations, limited by some technical restrictions. It may take some time to cultivate the entire industry. Next, let's make a summary. That is our key performance indicators of 5G. Of course, we are comparing with 4G. Below are some of our current 4G indicators. Above is an indicator after our 5G. We compare from latency throughput, connection number and network architecture. First of all, latency, we said in the 4G network era, the typical system latency is 30 to 50 milliseconds. But when it comes to 5G, we want to achieve a 1 millisecond end-to-end delay. In this case, our overall improvement is 30 to 50 times. Another one is our rate, or we call it throughput. The typical value in the 4G era is 100 megabytes. Of course, this 100 megabytes is the rate we say 3.9G. We have some enhanced technologies in 4G through this carrier aggregation. We provide LTA, the basic standard of LTE advanced. We can also increase the rate, even reach a rate of 1 Gbps. But it and 5G's 10 Gbps, even 20 Gbps rate, there is still a clear gap. Another one is our connection number. The typical connection capability of a cell in the 4G era is at 10,000, that is 10K. In the 5G era, our indicator is per square kilometer will exceed 1 million connection capabilities. So its connection capability has greatly improved. Of course, the last one is that the 5G network will support slicing, because we just saw the 5G network. We defined 3 application scenarios, eMBB, URLLC and mMTC. But these 3 application scenarios, the requirements they put forward for the network are different. eMBB's requirement for the network is to support higher rates. mMTC's requirement for the network is that it needs to support a larger connection capacity. URLLC's requirement for the network is that it needs to support lower latency. But how do I meet the needs of different business applications on a physical network? In fact, slicing will be a good implementation plan. I divide a physical network into different logical slices. Different logical slices, it implements different demands to meet different business applications. So in terms of network architecture, we want 5G network through slicing. It can well meet the demands of differentiated applications to better support vertical industries. But 4G does not have this slicing capability. Our future 5G network through NFV and SDN technology obtains such an end-to-end slicing capability. Through this end-to-end slicing capability, we can better support the differentiated demands of vertical industries. We can more effectively change our traditional industry, promote the digital transformation of traditional industries. So we would say 5G will become an enabler of the digital transformation of traditional industries. Okay, this is our summary of the key performance indicators of 5G. Just mentioned our slicing, mentioned our vertical industry. In fact, 5G has the ability to adapt to the needs of vertical industries, because we will find that the differences between different businesses are very large. The demand for the network is completely different, and the 5G network has the ability to adapt to different business demands. We implement it through slicing. For example, some of our virtual reality VR businesses, in fact, its typical demand is the need for high speed, but for these sensor type Internet of Things services, like our water meters, gas meters, electric meters, or parking, it just requires a connection number. Its speed and latency requirements are very low. We go to the water meter to report a reading. We are 1 second late, 10 seconds late. The problem is not big, but the number of our meters will be very large. So this kind of sensor type business, it requires connection capability, but its requirements for speed and latency are not obvious. Or what? The requirements are very low and are what? The business of automatic driving, its requirement for latency is very high, but its requirements for speed and connection capability are not obvious. Of course, it also has requirements like our automatic driving scene. The data detected by our vehicle's camera and radar also need to be reported to the cloud. It also requires speed, but our upload speed requirement may be 10 megabytes, 20 megabytes, 30 megabytes. That's about it. That's enough. But its typical feature or most obvious demand is latency. Of course, we also have some other business applications such as remote control, mobile video office, etc. But we will find that different businesses, the requirements for the network are different, how to adapt to different business needs through a physical network. In fact, this is a key capability of our 5G network. It can be sliced, make itself have such an adaptation capability. This is a key capability of our 5G. Through such a flexible adaptation capability, through such a flexible network, 5G can well adapt to the differentiated needs of vertical industries. Finally, let's make a summary. We saw the future 5G network. Not only will it provide VRAR services for us individual consumers, it will also provide certain services for some of our vertical industries, such connections like water meters and gas meters. It will provide our driving services, even provide our industrial control, such functions. So we will see the mobile internet for individuals and the mobile internet of things for industries will merge together in 5G through this 5G network. We can meet the needs of the mobile internet and the needs of the mobile internet of things. So we say 5G will become a platform. It will become a platform that enables vertical industries and a platform for our ordinary consumers. So we say 5G is a platform for new applications, new business models, and a platform for new industries. Through the 5G platform for telecom operators, it can provide traditional voice and video services to ordinary consumers, and it can also provide differentiated slicing for vertical industries, enabling the digital transformation of vertical industries to expand some new businesses, new business models. So we summarize in one sentence, that is, 5G will become a platform for industries, a platform that enables vertical industries. But for the operators themselves, this 5G network also needs to be easy to deploy and maintain, and it needs to have enough flexibility to enable our new vertical industries. This is our first part, that is, the driving force of our 5G development. We mainly introduce what 5G is, what capabilities does 5G have, what new businesses and applications can 5G enable, what new businesses and applications can 5G enable.